continue with the topic Group 2 Elements in Organic Chemistry Part 2. Okay, before this, we have learned about the physical properties of Group 2 elements such as the atomic radius, the melting and boiling point, ionic radius, electronegativity, and so on. Okay, so in this video, we learn about the chemical properties of Group 2 elements. Okay, the thermal decomposition of Group 2 elements. Okay, so Group 2 element, example, we have magnesium, calcium. Okay, so next we look at the thermal decomposition. So the thermal decomposition depends on, first, the charge of the ions. Okay, the higher the charge on the ions, the more stable the ionic compound. Therefore, more energy required to overcome the attractive forces between the ions. Okay, number 2, the size of the ions. The smaller the size of the ions, the more stable the ionic compound, because they are held together by stronger attractive forces. Okay, so these two thermal decomposition depends on this factor. Okay, first we look the thermal decomposition of magnesium nitrate. Okay, heat magnesium nitrate in a test tube and observe. Okay, the reaction is produce brown gas. Okay, you can see the brown gas. So brown fumes are liberated and glowing splinter is rekindled. Okay, biasanya kita gunakan glowing splinter ni untuk detect the oxygen gas. Okay, so bila glowing splinter ni menyala, menunjukkan kehadiran oxygen gas ada di situ ya. So, what are the product formed from this reaction? Okay, we look at the equation. So, from magnesium nitrate, okay, we can get magnesium oxide, nitrogen dioxide gas, and oxygen gas. Okay, jadi yang brown fumes tadi tu ialah nitrogen dioxide gas. Okay, so dia ada produce oxygen gas. Okay, ini yang menyebabkan glowing splinter tadi menyala. So the thermal decomposition of group 2 nitrates, okay, this one we put here M. M represented the group 2 elements. Okay, so M can be beryllium, magnesium, calcium, strontium, or barium. So this is the general equation of thermal decomposition of group 2 nitrates. Okay. Next, we have magnesium carbonate. Okay, so we look at the thermal decomposition of magnesium carbonate. Okay, we heat magnesium carbonate in a test tube and the gas involved is passed into lime water. So, what is the function of lime water here? Okay, to detect the presence of carbon dioxide. Okay, jadi kegunaan lime water di sini adalah untuk mengesan kehadiran carbon dioxide. Okay, kita tengok dia punya reaction. Okay, dia menghasilkan gas, kemudian gas tu disalurkan ke lime water. Okay, what happened to the lime water? Okay, you can see here the lime water become cloudy. Okay, so menunjukkan memang ada carbon dioxide gas yang dihasilkan lah. So from magnesium carbonate, it will produce magnesium oxide and carbon dioxide gas. Okay, this is the general equation for thermal decomposition of group 2 carbonates. Okay, M, okay, sekali lagi, M represented of beryllium or magnesium, calcium, strontium, or barium. Okay, so this is the general equation. Okay, another one, we have thermal decomposition of magnesium hydroxide. Okay, so we heat the magnesium hydroxide in a test tube. Okay, observe the blue cobalt 2 chloride paper. Okay, mula-mula the cobalt 2 chloride paper is in blue color. Okay, kita panaskan. Okay, as you can see, the decomposition produce a gas. Okay, and the gas turns the cobalt 2 chloride paper to pink. Okay, the blue cobalt 2 chloride paper turns pink. Water vapor is formed upon heating. Okay, semasa dipanaskan dia menghasilkan gas wap air ya, vapor wap ya. So the equation for this thermal decomposition of magnesium hydroxide is produce magnesium oxide and water. Okay, water in gaseous state. So this is the general equation for the thermal decomposition of group 2 elements. Okay, M representative of beryllium, magnesium, calcium, strontium or barium. So nitrates, carbonates and hydroxides are of group 2 elements are very stable. Okay, kalau awak tengok tadi kita ada magnesium, nitrate, carbonate and hydroxide. Persamaan dia bila kita panaskan semuanya menghasilkan magnesium oxide as a main product. Okay, main product dia mesti menghasilkan magnesium oxide. Okay, however, this compound decompose to form a metal oxide when strongly heated. Okay, ni untuk magnesium nitrate, magnesium carbonate and magnesium hydroxide. Okay, if we look here, okay, all the nitrate, carbonate and hydroxide will decompose to form a metal oxide. Okay, why do carbonates, nitrates and hydroxides of group 2 elements decompose to their corresponding oxide? Okay, kenapa carbonate, nitrate, hydroxide ni dia akan decompose, dia terurai kepada dia punya metal oxide. Okay, kita akan tengok the difference between okay, magnesium carbonate and magnesium oxide. Okay, as we can see here, okay, the size of an ion is different, okay, compared to cation, okay, metal ion. So metal here, okay, size of metal ion is the same, okay, sebabnya kita menggunakan elemen yang sama iaitu magnesium. That's why size of magnesium ion is the same. Okay, but the size of an ion here, carbonate ion is larger than oxide ion. Okay, macam yang saya cakap sebelum ni di awal-awal video tadi, thermal decomposition ni dia bergantung kepada dua faktor. Okay, iaitu the charge and the size of the ion. Okay, so here size of oxide ion is smaller than size of carbonate ion. Therefore, the oxide ion is more stable because the stronger attractive forces. Okay, so tarikan antara magnesium ion and oxide ion is stronger than magnesium and carbonate ion, menyebabkan the compound, okay, this compound magnesium oxide is more stable than magnesium carbonate. Okay, that's why bila kita ada magnesium carbonate, they easily decompose to magnesium oxide because magnesium oxide is more stable than magnesium carbonate. Okay, same explanation goes to group 2 nitrates, okay, and group 2 hydroxide. Okay, sama jugalah. Kalau nitrate tu, size of nitrate ion is bigger than oxide ion. That's why the magnesium oxide is more stable than magnesium nitrate. Okay, this shows that oxides are more stable than nitrates, carbonates, and hydroxides. This is because the oxide ion with its smaller size and higher density can approach the cation ion more closely. Hence, more energy required to overcome stronger attractive forces between ions in magnesium oxides, okay, in metal oxides. Okay, that's all for thermal decomposition of group 2 elements. Okay, we meet again in the next video. Bye.